Class 9, chapter number 5, Introduction to Euclid's Geometry. Uh, Before starting this chapter, we will learn some basic terms used in this chapter. Let's start. Okay. In this chapter, we will use two words, axioms and postulate. So, what is this axioms and postulate? Let's understand. Okay. Both axioms and postulate are assumptions which are obvious universal truth. Now you may head out. What is obvious universal truth? Okay. So, obvious universal truth means what? If we add 5 plus 2, we will get 7. If we do this at this time after 5 years, we will get same answer, because this is the obvious universal truth. Okay, but they are used to prove other statement. Now axioms and postulate are used to prove other statement. This is the some expressions like uh, if x square minus y square, you will get x minus y, x plus y. You can use this expression to solve this identity to solve other example like this. Axioms and postulates are used to solve some of the examples. Let's understand. Okay, before that, what is the difference between axioms and postulate? Okay, let's understand first postulate. Postulates are assumptions that are mainly related to geometry. This postulate is used in geometry, while axioms are the assumptions that are not mainly related to geometry. Doesn't mean that we will not use these axioms are not used in geometry. One word mainly is there, means we can use, but rarely these axioms are used in geometry. Okay, now one word theorem is there. What is theorem? Theorem are the statements which are proved using the definitions, axioms and previously proved statement. Okay. And we will use this theorem to solve some of the examples. Okay, now we will learn some of the Euclid's axioms. There are 5 axioms are there. First one, things which are equal to the same thing are equal to the other. Let's understand by small example. For example, if x equal to 5 and y equal to 5, so we can write x equal to y. This is our first axiom. Next, if equals are added to the equals, the wholes are equal. Okay, let's understand this axiom by one example. If x equal to y, if we add 5 to both sides, we can write x plus y equal to y plus y. Clear? Third one, if equals are subtracted from equals, the remaining are equal. Same thing. If x equal to y, subtract 5 from both sides, means x minus 5 equal to y minus 5. Done. Next, things which coincide one another are equal to one another. Okay, you cannot directly understand what does this sentence indicate. Let understand by small example. If I draw one line, say AB of 5 centimeter, one another line of CD of 5 centimeter, so we can say that AB coincides with CD. Okay, so we can write AB equal to CD. But in this chapter, we will use this axiom like this. This type of example is there. Let's understand. Okay, if I draw one line, say AB, and take one point on C, so we can say that AC plus CB means this part and this part. AC, if we add this, we will get AB. AC plus CB coincide with AB, or we can write, so we can write AC plus CB equal to AB. This type of example will be there in our chapter. And fifth one, the whole is greater than the part. Okay, if I take one example, this is the whole part, this is whole part, and if I take one part out of this like this is a part. So if I take this as a 1, and this will be 1 by 4. So whole is always greater than part. So 1 is greater than 1 by 4. You can take 1 half here, no problem. Okay, now sum of Euclid's postulate. First one, a straight line may be drawn from any one point to any other point. If I take one point here and another point over here, if I join these 2 points, I will get straight line. Means a straight line may be drawn from any one point to any other point. If we take any 2 points and join, if we join these 2 points, we will get straight line. Anywhere, if I take one point over here, another point over here, if I join these 2 points, I will get straight line. Next one, a terminated line can be produced infinitely. Okay, if I take one line like this line doesn't mean that this much part only. Here this arrow sign indicate that it can be extended to both sides. So this, the meaning of this sentence, the terminated line can be produced infinitely. We can extend line. Third one, a circle can be drawn with any center and any radius. Okay, in this circle, O is center. If I draw like this line, we can say that this is the radius of circle, OR. OR is the radius of this circle. Same way, if I take one another point, another radius, if I draw this circle, we can say the center is P and this point is Q. So PQ is the radius of this circle. So we can draw any circle with any center and any radius. Next, all right angles are equal to one another. You know that right angle means 90 degree. Let's take one example. Let's say angle ABC equals to 90 degree. Angle BCD equals to 90 degree. Let's take one more example by figure. We can say this x angle is 90 degree. We can say this y angle is also 90 degree. So we can write angle ABC equals to angle BCD equals to angle X equals to angle Y. Means all right angle are equal to one another, because right angle means 90 degree. Now last postulate. If a straight line falling on two straight line make the interior angle on the same side of it taken together less than two right angle, then the two straight line if produce infinitely meet on that side which the angles are less than two right angle. Okay, let's understand. Let's take this two line. Now if one straight line is fall on this one straight line, make interior angle on the same side. Let's take this angle as a x, this angle as a y. Okay, now if taken together this two angle is less than two right angle. One right angle means 90 degree, so two right angle means 90 plus 90 180 degree. Clear? So this statement indicate that if you add this two interior angle on one side, the sum of this angle is always less than 290 degree, means 180 degree. And then the two straight lines if produce infinitely meet. If we extend these two line meet at this point, okay, on which the angle are less than two right angle, means this angle form is always less than 180 degree. Okay, now one word corollary is there. What is corollary? Corollary means result deduced or obtained from a theorem is called corollary. If you simply check the last result of the sentence, any theorem, you will get one like identity. If I write x plus y square, x square plus 2xy plus y square, this identity is also proven by one theorem. So at last whatever we will get in the theorem is called corollary. Okay, this was the introduction part. In next video we will learn exercise number 5.1. Thank you.